working. Oh no. So hold on. We're gonna have to pause. Okay, now we're ready. So it says draw and label the diagram. So I know that we have a block, so we're gonna go with that. And then it says pull the scale with the force of 5 newtons. So we're gonna go one this way in one direction because it's only one scale, and then I'm gonna label it 5N. That should be about what it is. So if you're calculating the net force, right, hopefully this one was a little bit easier. So you'd be like 5N plus, and there's nothing over here, so we would just say 0N. And I'm going to go like this because I don't want it to look like it's like on. So that'd be 5 newtons to the right there. Okay, cool. Do the forces applied result in a change in motion? The answer would be yes. And it says to describe it, so make sure you describe it. It looks like it just moved in one direction. And then if this represents, does this represent a balanced or unbalanced? And we would say unbalanced, because unbalanced will result in acceleration, and that is what we saw. So now this one says hold the block down, attach a 5 Newton spring scale to the rubber band at one end, and attach a 5 Newton spring scale to the rubber band at the other end. So then this time it's going to look like this, right? Boom, and then bam, and then 5 in, right? And then 5 in, okay? And then calculate the resulting net force. So that would be like this, 5 in, and we said put the largest one first. However, there is no largest one, and since these are working against, we're also going to subtract, and then we're going to put it that way, and then the resulting force is going to be 0 in. So 0 newtons, and what we should have saw was little to no movement. I'm going to move myself up out the way, and then did the net force result in a change of motion? And we would say no movement, right? That's what we saw, no movement. Okay, is the representation balanced or unbalanced? We would say balanced in that case. Okay, now this says hold the block down, 5 Newton spring scale with the rubber band at one end, and then a 10 Newton on the other end. So now we're going like this, boom. And then it says pull 5 newtons on one end of the scale, and then it says pull with 10 newtons. So it says go like this. We're going to put this as our 10, okay? And then we're going to go that way and then say this is our 5 Newton, right? And then calculate the resulting net force. So again, you're going to put your largest one first, 10 newtons going that way, minus, since they're against, 5 newtons going back the other way, right, because they're pulling against each other, is equal to, is equal to, I'm going to scribble that right there. I'm going to say 5 newtons, and then the 5 newtons should be going to the right there. Calculate it. So, as you can see, this is going to result in acceleration. I would say acceleration, right? Ooh, to the right. That's what I saw. But not a crazy amount, but a little bit to the right. Okay. Hold on. Let me double check my... The video looks like I'm frozen, but I am not certain. I'm going to keep going because it says it's recording. Is this representative of the balance or unbalanced? And I would say unbalanced. Okay, on to scenario 4. Let me move myself up out the way. Oh, now I'm talking. I don't know. Hopefully it was working the whole time. So it says hold the block down, attach a 10 Newton spring scale to one side, and attach a 5 Newton spring scale. Attach 2 5 Newton spring scales to the other side. So this time it's going to be like this. And I made it a little bit taller because I need to be like, and put this as 5 newtons, and then, and this is what we had, right? 5 newtons, and then 10 newtons, right? Okay, so calculate. So always put the largest one first. So these are working against each other. So I'm going 10 newtons, and I'm going this way. Subtract. Now watch this. Someone did this in class. It was uber genius. Plus, and they put the parentheses, and the awesome thing about the parentheses is it says to add those forces together before you subtract, right? So that is actually what's going on there. So 5 plus 5 is 10. So 10 minus 10 ends up with 0. So the prediction is 0 is no movement. That would be the prediction. Now, is that what you guys saw in the lab? That is what I saw. Little to no movement. Does this represent balanced or unbalanced? And again, I would say balanced. Balanced. Okay. So that is everything. So again, you're going through each scenario, doing it, and then you're calculating it. And then does what you see and what I saw, it lined up with what we actually did, and then that's how you can tell if it's balanced. So you see, when it's balanced, you see no movement or no acceleration. That's really what it is. We don't see an acceleration. We don't see a change in speed. But when it's unbalanced, then we see acceleration, and we see a definite change in movement, okay? Or a change in motion. All right, so let's go over here to the conclusion, and let's see how we're doing. How do balanced and unbalanced forces affect an object's motion? Well, we just said what it was. So if it's unbalanced, then it seems like there's a result in a change in motion or direction or acceleration. And when it's balanced, we see no change in the movement. No change in the movement. And that probably would be a better answer in there where we said no movement. Well, we saw no movement because it wasn't initially moving, but it's no change in movement, okay? So if an object is accelerating, can we safely assume that this is an unbalanced force acting on it? What would you guys say? I would say yes. If an object is not moving, I would definitely answer yes to this. You do need a complete sentence. I'm just going to write yes, but you need to say why, right? So you need to say yes. It is, because that's what we witnessed, but why? So explain that. Explain that in there. Now, considering the concepts, I'm not going to do this one, and the practices of this activity, come up with a testable, that's the most important thing, it needs to be testable question that involves objects, their mass and forces, and acting on them and the resulting motion. So, how could we test out? Think about all the things that we've used in this classroom. How could we test this out? So I want you to come up with, again, a testable question, a scenario in which we could actually do in the actual class. If there's things in the school, I'm going to let it be the school, but it has to be stuff that we have access to, not like a bus. We don't have access to a bus where we can do an experiment like that. What do we actually have access to in this school where we can measure the forces, and then we could figure out if it's balanced or unbalanced, acceleration or no acceleration. So think about those things. Make sure that this page 56 is complete, because it might be what you're going to need to turn in. So make sure it's complete. All right, complete sentences, and make sure it's a testable scenario. All right, y'all. Peace.